Dear students, today we will discuss about further loop execution and we will discuss a very important practical example that how we can design an algorithm to basically find the maximum value in a list. So let's suppose we have this list which has 10 numbers starting from 12 until 45. So can you find the maximum number in this list quickly? Yes, we have found that the maximum number is 999. And what was the procedure? The procedure was your mind actually followed a specific procedure, and this was as follows. First of all, your mind took this 12 and compared it with 18, and when it found 18 as a bigger value than 12, then your mind left it and remained 18 in the mind. Then it compared 18 with the 299 and left 18, and then it compared 38 and left 38, and then it compared 299 with 999, and then it remained 999 in your mind. And then when 999 was compared with any of other values until the last of the list, so we found that 999 is the maximum number. So this was the procedure your mind has worked. So this means we can work fine, our mind has worked fine when we have only 10 values. However, if we have million of values and we want to find the maximum number out of those million values, it would be very tricky and it would be very lengthy procedure. So let's make an algorithm of it that whatever the size of the list is given to this to the computer, to this algorithm which we will be developing, that algorithm can find the maximum value from this list. So first of all, we need to see that we should need to traverse this list from start until end. So first procedure could be that we, as our minds did, that let's have a maximum number max, and we assign first number in the list. So first number in the list is assigned to the max value, and then the second value in the list is assigned to current value which we want to compare. So this means max has 12 at the moment and current has 18 at the moment, and we will be comparing 12 with the 18, and if max is less, then current value will be assigned to the max and we will move forward. And until when we will be doing this procedure? Until we have the list. So this means we can use a while list remains. So until when we have any element in the list, we will keep on working, keep on executing this loop, and the condition could be if max is less than current. Max is assigned by current and current is assigned to next value in the list. So let's try to execute it. So we have a RAM over here. Max has initially 12 and current has initially 18. So while list remains, yes, list remains. If max is less than current, so 12 is less than 18. Condition is true. So current is assigned to max. So max becomes 18. And current is pointing to the next value. So current is now pointing to 299. So then it is moving again, moving to the next iteration because list remains. This loop is true. If max is less than current, max is 18 and current is 299. Yes, the condition is again true. So 299 is assigned to max using this statement. So 299 comes to max and current is moving to next location, which is 38. Then it is coming again. The condition of loop is correct. Then it is again checking if max is less than current. So 299 is less than 18, condition is false. So it is leaving this position. Then it is moving the current to the next value, which is 999. If 299 is less than 999, so the condition is true. So this true means 999 will become the max and current will be moved to 89. And then you can see until the list ends, every time this statement remains incorrect. However, this statement keeps on running because this statement is not part of this if statement, and this 101 is coming in the current. As max is greater than 101, there is no change. Then current is moving to 500. There is no change. Then current is moving to 801. Still max is maximum 999, no change. Then current is moving to 45 and it comparing with 999. Again 999 is maximum, no change. And then your while loop terminates because of this statement that list doesn't remain anymore. So this is basically an algorithm of 1, 2, 3, 4, 5, 6 statements, and you can assign this algorithm as a definition of function. You can write at the top def find max. So this is the function structure we have made. And in this statement, we have learned that the last statement is not part of the if condition. This will be keep on running whether the if statement is true or not. So if we summarize today's module, we have learned a very practical example of how we can define or discover algorithms based on some problems, and we have taken the example of finding maximum value, which was the actual problem which we will be focusing. And to solve this problem, we learn from our mind that how our mind has tried to solve this problem, and in the same way we have built or discovered the algorithm which we have written in the pseudocode format.